Now that multi-stage launcher, here we have that PSLV C18. So it has a stage 4, that we just go with one by one there, and the stage 4 rocket here with a point 0.8 to ton liquid propellant here, and that will be providing, see that vertical, providing a maximum thrust. Okay, that will be of what you can say that that uh, 7.3, okay, into 2, and we can say that that's about Kn here, and that mixture is used mmh. You can say that that particular mixture, and you can say that this one is about a mixture there. Then another is about, we can say, a stage 3 rocket, that with a 7.6 ton propellant, that can say solid propellant, and that will be providing 247 kn. Okay, that will be a maximum thrust, and that material is used what, STPB based. Okay, then another stage, that is about, you can say, a stage 2. This one is about a stage 2 here, and in a stage 2 rocket with 41.7 ton liquid propellant, providing providing 799 kn maximum thrust. Okay, then that is the stage 1, and then this one is about nothing but a stage 1, and the stage 1 rocket with 138.0 solid propellant, providing 4800 kn kilonautical wave. Okay, that maximum thrust. Okay, this one is about a maximum thrust, and that material is used what, HTPB. And then with this, okay, so along with this particular stage, they have the booster rocket. Along with that, they have the booster rocket with them, and that booster rocket motor. So that is about the PSLV C18. And that we say that a liquid use, STBB means what? A hydroxyl terminated polybutadiene. Okay, and we can say that again another is about N2O4. It is to be used. That is called as a nitrogen trioxide, and that is a mixture of a oxygen and hydrogen there. Another propellant they have used, that liquid propellant, is about a hypergolic propellant. So now each and every stage, okay, each and every stage they have the different thrust. Okay, that propellant is to be used. So solid propellant and a liquid propellant. So mostly that they are using a solid propellant to get the thrust there. that required thrust for launching this particular satellite. So if you see that particular first, we can say that in stage one they have this particular propellant along with that booster rocket, and that is the booster rocket providing the additional thrust. Okay, they are providing the additional thrust to launch the vehicle. So most of the time, what happens? So initially, that rocket launching fails means what? This booster rock motors or this stage one is failed. In that case, there may be a problem of launching the vehicle. Mission fails only at the initial stage only. So they stop everything. They are not hitting this particular stage one or stage two, and they stop all the things. Okay, at the same time. So ISRO is supposed to be, we have that okay, Indian Space Research Organization. They have developed their own launch vehicle, and that launch vehicle developed by the ISRO, that is called as a SLV. It is called as a satellite launch vehicle. Then another vehicle it is to be launched, that is augmented satellite launch vehicle. Okay, ASLV. Then a PSLV, that is about a polar satellite launch vehicle. Then a GSLV, and that is called as a geostationary satellite launch vehicle. So these are about the launch vehicle developed by this ISRO, and then most launch vehicle they are using nowadays, that is about a PSLV or a GSLV. So if satellite is to be placed in a geostationary orbit, then GSLV. If your satellite is to be placed in the polar orbit, then PSLV. So that satellite placed in a geostationary orbit means that will be on a equator plane, so that will be fixed. So they are used only for the transmission purpose in a given coverage, okay, communication purpose. But if you consider that a PSLV satellite, they are moving around the Earth there, so that can be useful for the that remote sensing or any other application there. Okay, so we say that according to the application that particular launch vehicle is to be used. Again, that is not the issue here. So consider that satellite in a given orbit to be sent. So then there are the various methods to send the or to launch a satellite in a given particular orbit. So here we consider one example, that is about a geo launch. Geo launching means what? A geostationary satellite. So means we can say that a launcher, or we can say that a launching vehicle that is to be used supposed to be by the Indian government, that is to be a GSLV, geostationary satellite launch vehicle. But now that then we should know that what will be the place of placement of this particular satellite. Okay, so we can say that uh, that launchers we are using that in a particular launcher site. So whichever the launchers we are using in this particular launchers used, okay, which launchers used in the launch or at the launching site there, we can say that that will be toward the eastern direction. Okay, in the eastern direction. Okay, okay, so we can say that easterly direction, eastward. Okay, so or we can say that eastward. So we can say that that is to be whichever the satellite launch there, whichever the launchers are there. means placement. So that's why we have a place that is about a stereo ricotta, that is the launching site, and that launching site is already it is in a easterly direction. Why we require it in eastward or easterly direction? Because our Earth is rotating around the sun in a eastward direction, okay, or easterly direction. So to take the advantage of Earth velocity, okay, to take the advantage of the Earth velocity, the launchers or launching site is to be in the easterly direction. So means for a given particular launchers, we say that it is in a eastern direction. So what happened? Earth is rotating, so that's why Earth is have the velocity or whatever the we can say that velocity of that Earth spinning in the given axis. So that velocity that automatically okay available to this launching site. This launching site has the velocity of easterly direction there because of that Earth spinning on its particular axis, and that because of that that velocity will be get by this launch vehicle or a launching site. So means in another way we say that that particular velocity is imparted to the launcher, okay, in addition to that velocity required by this particular rocket engine or particular thrust there. So generally we say that that velocity we consider it is to be a maximum either of a 465 meter per second, and that velocity is okay, that velocity is added to the velocity of a rocket launched from the equator, if supposed to be on equator. So means we will take that particular velocity, maximum velocity. Why we are use maximum velocity? Because according to the position of that particular uh, launching site on what latitude, okay, so based on that particular site, that much velocity automatically added or imparted to the rocket engine. So that's why we can say that that maximum velocity will be added to the rocket that will be launched from on the equator there, and that added velocity that will reduce the at a higher absolute values if we consider for the given particular latitude there. So whenever we place a satellite in a geostationary orbit, so always we use that equator there. Okay, to place the satellite in a geostationary orbit, we always use the equator there. Means placement of a satellite on this particular equator plane we consider. So that's why we consider that it is to be on the equator itself. Okay. So then even another ways are also there. Instead of that, we can use a different place or a different place, and we can launch a satellite or place the satellite in a different orbit. But to place the satellite in a geostationary orbit, or we can say that in a geostationary orbit or a geo orbit, so directly satellite could not be launched in a geo orbit. So we could not launch or we could not place the satellite in a geo orbit. So we need to place the satellite in a geo orbit. So we need another orbit, and that satellite is to be placed in another orbit, and then we need to transfer that particular orbit to the geo orbit. So we can consider that generally whichever the launcher we are using, that launcher, that whichever the launcher are there, they place a satellite in a geo transfer orbit. Okay, initially we need to place the satellite in a transfer orbit, and then after geo transfer orbit, once we place the satellite in a geo transfer orbit, then after that, that is to be placed in the next rotation, that is to be transferred to the geo orbit. Okay, so that is called as a geostationary, or you can say a geosynchronous. Okay, so word we are using that satellite in a geo orbit, we can consider that it can be we can say a geosynchronous one. Okay, so that we that a particular orbit GTO is nothing but a geosynchronous orbit or geosynchronous transfer orbit, because transfer the satellite in the geo orbit. So likewise, we can use that particular launch vehicle. But once we launch a satellite or place a satellite in a geostationary orbit, so in that case, that we say that the satellite is launched. So we say that apogee and perigee. Okay, this is about your can say that the apogee and perigee. Which initially it is to be launched in a GTO orbit. So apogee and perigee will be changes. So we need to use a motor, apogee kick motor or a perigee kick motor to transfer that satellite in a given orbit. So that if it is a geostationary satellite, okay, if it is a geostationary satellite, then satellite is to be in a circular orbit. Then we need to transfer that apogee and perigee is not to be there. So it is to be in a circular. Your satellite is to be rotating in the circular orbit. So we consider that how your satellite it is to be launched from the uh, that from whatever the geotransfer orbit or whichever the orbit raising method that we launch it. So generally we consider in initial case that orbit will be a elliptical one. Okay, we are getting that orbit will be elliptical one, and then we need to transfer the satellite in a geostationary orbit so that we'll get that a circular orbit. So we need to convert that elliptical orbit to the circular orbit at the time of a transfer of the orbit then. So that method of transferring from the elliptical to the circular one, that is called as a orbit raising method, and that orbit raising method is to be used for the launching the different satellite at a different places. Now consider here we can one example we'll see here now. This one is about our Earth now. Okay, this is about our Earth, and a satellite is to be launched, and this is about a orbit of a satellite. So in that case, nearer to the Earth, nearer to the Earth, that is about a perigee, or far away from the Earth, that is about the apogee. So now this one is nothing but a geotransfer orbit. This orbit is called the geotransfer orbit. Now then, what happen here? Perigee will be nearer. Okay. Now here apogee. Okay, this is about apogee is a far away from this. Now we need to transfer the satellite in a geotransfer orbit. So whatever the distance that is about apogee here, whichever the height we consider, that height is nothing but what? A satellite from the center is about 41 something, or altitude from this to this is nothing but a 35,000 something kilometer. So means we need to initially satellite that altitude is to be okay match using this apogee there, and then apogee kick motor will transfer the satellite in the given orbit. So now this one is a circular one. Now this one is about a circular one. So another method is about what? This one is a geo transfer orbit, or this one is about a geo orbit. So initially it is about a GTO, then it will be a geo here. So now here, whatever the radius of, or we can say the distance from the center of the Earth to the apogee, that will be nothing but the altitude of this geostationary satellite. So that's why this height we can consider. Another example, if we consider here, we have the Earth. Now we say that initially we consider that now this one we can say that is about a perigee, and this one is about a apogee now. Okay. Then another way is about what? Perigee. This one is to be fixed now. Okay. This one is to be fixed now. Then we can transfer the satellite to an orbit. Again, from this elliptical. Okay. Again, this one. This one is the perigee fixed. This one is about apogee. This is for the one. This is for the two now. And then from this we can get the circular one. So that is called as a geo orbit. So we can say that initially, okay, initially this one is about a LEO orbit. Then we can say that this one is about a geotransfer orbit. Why geotransfer or word geotransfer? Because altitude is expecting in a geosynchronous orbit is the same there. So that's why I can say that about a geosynchronous orbit here, or that altitude we are getting transferring the satellite from the LEO orbit to the GTO, and from the GTO to the GEO there. That is what a orbit region. Or here we can consider that a apogee, okay, a apogee here in this case perigee is a constant, only the variation in the apogee there. Okay, only the variation in the apogee. So there is a why that. Okay, now another one example, we say this one is about the Earth. We can consider that a perigee and a apogee there. Apogee is far away from this satellite, and this one is nothing but a perigee. This one is a near one. This one is a far away from this. Okay, perigee. Apogee is far away from this. Then this one is, we can say that is about a perigee one. Then from this one is about your can say apogee one. Then transfer the orbit from this to this. Now in that case, this will be the A2, and this becomes a P2. Okay, this particular is nothing but a P2, and this one is about a A2. And then from the A2, okay, then from the A2, we can say that eh, that's about a geo orbit. This one is about, you can say, a GTO orbit, and this one is about a LEO orbit. Now in that case, apogee and perigee changes now, because we are transferring the orbit there. Because here we are saying that orbit is changing. Another way is what, we just keep the changes in the what apogee and perigee, just like we can consider that this one is about a fix now, this one is about fix now. Okay, likewise. So we can consider that you can use directly the transferring the orbit there.